All right, so today's lesson we are going to talk about rocks, how scientists classify rocks, and then specifically about igneous rock. Okay, so first we're talking about classifying rocks. And if you look, so you all have your pet rock in front of you. And one of the things we're going to do over the course of the next couple days is hopefully figure out if your rock is igneous rock. How exciting. I bet you thought we weren't going to get back to this. So this rock is called conglomerate. Does anyone know what the word conglomerate means? It's used outside of science and rocks as well. It means what? No. Conglomerate or a conglomeration? No. A conglomerate just means a bunch of different things stuck together. So conglomerate rock is rock. It's usually sedimentary rock, which we haven't talked about yet. And I know there's another picture here in a couple pages. But basically, it's a rock where a bunch of stuff is stuck together. And sometimes when you see it, it's really obvious because it just looks like things. Here on page 96, there's another picture of it. So right here, this is looking at it closer up, and it's what you call poorly sorted. You can see sand and gravel and rocks of all different sizes, and then it gets kind of cemented together. And so, what's that? Usually from pressure or chemical changes. And so that's sedimentary rock that we'll talk about the week after the unit test. But yeah, it gets cemented together. Actually, concrete, you know how you make concrete for sidewalks or whatever? You take the cement mix and then mix it with water, and then you usually put gravel and sand in with it. That is actually a man-made conglomerate rock. And that's a chemical change. You know, it gives off heat as it dries, and then once it's dried, getting it wet doesn't dissolve it. So concrete is actually a conglomerate rock. So we'll come back to that. If your pet rock has really big chunks in it and is, you know, kind of relatively soft, it could be that. But let's go back here a minute. When we talk about how scientists classify rocks, it's pretty obvious things, as we read about yesterday. It's things like, what does it look like? What's its color? And what do the grains look like? And so this is one of the things we'll see. This is granite, which actually is an igneous rock, which always was strange to me at first, because when I think of igneous rocks, I think of lava, just the absolute lava rocks that are black. But here you see it made up of different things. You see quartz, which is the shiny things. Around here, quartz is a very common mineral or rock, and so we see a lot of that. Feldspar, which can also be pinkish. Hornblende, which is blackish. And mica, which is another kind of sparkly black rock. You guys are probably familiar. It's shiny, and it flakes off into thin flakes. So quartz and mica are something we're really common around here, and we're able to see. So when you look at the minerals that make up the rocks, in some rocks it's pretty easy to see, oh, look, there's a bunch of stuff making up this rock. And granite is one of those. And as you look at your pet rock, I'm sure that some of you have granite rocks. And when we talk about uses of rocks, we'll figure out why that is. Let's look at, and next week we'll talk about, or in a couple weeks we'll talk about minerals, which are the parts that are making it up. So the different grains, and again, we'll go over this in more detail when we look at all the rock types together. Mostly what we're going to see, so there's fine grain, it's all going to look the same. Coarser grain. This says no visible grain, but I think that's kind of a not a great picture. Something like obsidian would have absolutely no visible grain. Rounded grains, so you can see the gravel and sand. Jagged grains, some of the igneous rocks look like this from all the ash and cinders that are blown together and then stuck together there. And then we can also have things like this, banded, and the picture in your book is much better than this. The resolution here is not very good. But these ones are kind of smashed together like this. I always thought it looked kind of like fudge ripple ice cream. And they call that banded. It's kind of striped. And then non-banded, which means not striped. And those ones are generally not igneous rocks. So if your rock has stripes like this, it's not igneous. If it has some of the bigger chunks like this, not igneous. So, and if you're not sure, don't worry. We're going to learn more things. And again, just a brief overview. The 3 types of rocks. So you might want to write these down. The 3 types of rock. And this week we are only talking about igneous. Igneous rock forms when magma or lava cools and hardens. So it's always in areas that were volcanic at one time. And it was totally melted and then cooled. And that's where you get the characteristics of that rock. The sedimentary rock is formed in layers. And sometimes it's very obvious to see the layers. Sometimes it's things like the conglomerate where you can see they got cemented together. And then the metamorphic rock used to be sedimentary or igneous, but underwent extreme heat and pressure. Not enough to actually melt the rock, because then it would be igneous again, but enough to change it and make it, you know, kind of wobbly, stripy, or to change the sand-like things into crystals. Okay, so going back to the igneous rock, again, the 3 main types we're going to spend a lot of time on after the unit test as we move on to our other stuff. But since the igneous rock is formed in volcanic areas, it seemed like a nice natural thing to attach onto this. So igneous rock, we already did, and hopefully you also did this, is rock formed by cooling magma or lava, and it's formed in volcanic areas, always. What's the difference between magma and lava? Pretty easy difference. What's the difference between magma and lava? Yeah. Excellent. Magma is underground and lava is on the surface. Okay? And that's going to be important because as you imagine, if it cools underground or if it cools above ground, it's going to look very different. All right. So, and then directly related to that, and we talked about this a tiny bit when we talked about rock before. Intrusive is a type of igneous rock. So we can break igneous rock into 2 different categories, intrusive and extrusive. So intrusive, and hopefully easy to remember because it has the word in. Intrusive rock forms where? Inside the Earth's crust. So intrusive rock, does it form from magma or lava? Magma. Okay? So intrusive rock, and it cools very slowly because it's inside the Earth. And so it cools much more slowly inside the Earth. The magma cools, and it has larger crystals, things like granite, obsidian, and basalt. Now, I don't know if you remember our samples of basalt. The basalt actually has much finer crystals than the, let me see, we've got a picture here in a couple pages. It has finer crystals than the granite. The basalt is usually black. Do you guys remember where basalt is found? Yeah, along the ocean floor. And it's a little bit sparkly, and I'll pass around one of these samples again, as opposed to the granite. And you guys are probably familiar with granite. There's a lot of it. It makes up much of the Rocky Mountains, and we use it in building materials in our houses. The granite generally has pretty big chunks in it, big crystals. So which one's cooling slower, the granite or the basalt? The granite. It's got bigger crystals, and that makes sense because the basalt is under the ocean floor, and so probably the temperatures of the crust there are a little cooler. And obsidian's just kind of a weird one because it looks like it's just one big crystal, so I'm not sure about the... Obsidian is also known as volcanic glass. You guys know what obsidian is, right? Okay. It's really shiny, and it's really sharp when it breaks. There is some over there. Okay, so that's the intrusive rock. And now let's take a look at the extrusive rock. Okay, so now we're passing around samples of the obsidian, the basalt, and the granite. These are all igneous, intrusive rocks. They cool very slowly, and so you can kind of see what they look like and how simply the difference in how fast they cool can change how they look. The granite, you might look, 2 really different types of granite we'll see. Some of them have a lot of pink in them, and some of them are just black and white. And that has to do with the other minerals that are making up the crystals. Okay, so extrusive. Extrusive rock forms where? Outside the Earth's crust. Extrusive, like exit. It exits the Earth and then cools. And so this is going to be the kind of stuff that you think of. I always think of it as just lava rock. So it's lava. It cools quickly on the surface of the Earth. It has either small crystals or really not visible crystals at all. You can also have some that looks like it's actually literally ash flow that then solidifies into rock. And I'll pass out some of these. Pumice is the rock. Some of it actually has, it has air bubbles in it because it cools so quickly. The pumice is actually so light that it will float. And so these are the rocks we look at. The other one that we call lava rock is also called scoria. It cools very quickly, and as it cools, the gas that was compressed when it was liquid goes from being in solution in a liquid to turning into gas bubbles, and you see those as it cools. So we'll take a look at those samples also. Okay, and then I have granite here again, which specifically is an intrusive rock. This is a very common rock that we see in building materials, right? It's a very common right now in use in countertops. So granite is very commonly used in countertops right now. It's a very hard substance, and the question was, how do they get it to look that way? Do you just cut it, but the answer is yes, they have to polish it. So, they would sand it and polish it, but it's such a hard substance. It's good for countertops because it's not going to get scratched very easily. Right, and there's another piece, right, and so that's been polished on the side. The different colors are because of the different minerals that are in it. And so, honestly, using your knives on the granite countertop is more likely to damage your knives than the countertop. But if you took sandpaper to it, it would make it look much more ugly again. Okay, and so then finally, guys, most of the lava rocks have a lot of iron in them. They're very iron-rich rock. If the iron has been exposed to oxygen, then you get the pinker, redder colors. And the last section on igneous rock talks about building materials. And granite is used in buildings, right? Many of older buildings are actually made of granite. They've got granite stairs. It's a very hard material. It's a very durable material. And that's why it's used. More and more now we have, wood and steel and things like that. But especially older buildings, you see a lot of it. And again, most of the Rocky Mountains are made up of granite. And so it takes a very long time for them to erode away. Questions about these igneous rocks? Let's look at a couple of the rock types we talked about last week with volcanoes. These are also obviously volcanic rocks. These are obviously igneous rocks. But just tying in, these were on last week's quiz, and some people had a hard time with these. So you might want to rewrite these down. And again, these first two, these are Hawaiian names for these rocks. Obviously, the whole state of Hawaii is made up from volcanic features. One person on the quiz actually had a really good question. They said, oh, I think of Hawaii and I think of all those jagged peaks. And so I wasn't thinking of a shield volcano. The jagged peaks and the really dramatic kind of features you see in the older parts of Hawaii, that's just from erosion. There's so much rain there, and then the plants grow on it, and that's where you get the really dramatic things. But when you look at the island of Hawaii, the big island, that is a huge shield volcano. So A'a is volcanic rock with very sharp edges. It is, of course, extrusive. And the reason it ends up with sharp edges is it has a high silica content. Silica is another mineral, as we talk about minerals and mineral composition of rocks. And so it makes it very thick. So as it cools, it's very thick. And so instead of smooth, runny things like when we did the wax, imagine if you put a whole bunch of sand in the wax. So it was thicker, you get a really rougher texture as it cooled, and it wouldn't flow very well. Then the other volcanic, also extrusive rock, of course, Pahoehoe. And that, when we did the wax, that's exactly what we're demonstrating with the wax. So it's ropey, it's also extrusive, it looks like taffy, or it looks like ropes, or it looks like wax, and that's exactly the demonstration we did. As we continue talking about rocks and minerals, you got physical change, and physical changes happen, but chemical changes are what we're seeing as new minerals are formed, new substances are formed. So don't worry so much about these ones. We'll come along with these ones as we look at our next things on rock types. Questions about our igneous rock types? All right, so then you went through the rest of the chapter. I just pulled this up because I wanted to show you with the igneous rock, the question was, if you have any rock with just a bunch of different kinds together, does that make it granite? And no, the conglomerate rocks are a bunch of different stuff together, but these, the reason why it has those different crystals is because as it cools, the things are kind of separating out. And the colors, again, depend on what is in it. The mineral composition we talked about. Then last of all, we did talk about granite as a building material. Pumice is very soft, and it can actually be used kind of like sandpaper. And pumice rock is it's very gritty, and you can also have that same volcanic ash. I'll get out that volcanic ash we looked at as well. And the obsidian, the volcanic glass, is used for tools. You can imagine easily that being used for sharp tools and knives and stuff like that. And that's actually an igneous rock. Most of the rock, the flint and the chert that is used for blades, are actually metamorphic rocks, which are formed a slightly different way.